Hey guys, how's it going? Back here with another math lesson for you. This week we will still be working with rectangular prisms, but instead of surface area, which is concerned with the outside area of a rectangular prism, now we're working with volume, which is concerned with the inside area of a rectangular prism, or simply put, how much space is inside of a box or whatever rectangular prism you're using, okay? So we're moving into 3D objects now, okay? When you're doing the area of just squares and rectangles and stuff like that, that's 2D, it's a flat shape, right? Now we're gonna add in a new dimension. We're gonna add in height. As soon as you add in a third dimension, we're talking about 3D objects. 2D means length times width. 3D means length times width times height. It's another dimension. So for this, it's actually fairly simple. I think you guys are going to have a really easy time with this. The actual formula for doing volume of a rectangular prism is just length times width times height. That's it, okay? Just length times width times height. I just wanted to do a quick lesson to make sure everybody understood what I was talking about though. So we're going to go through one together, just like we did last week. I have this a little Kleenex box here, and we're going to find out how much area or volume is inside this Kleenex box. How much room is inside this box. So last week when we were doing surface area, we found out the total of all the sides to see how much area we had on the outside of the box. This week we're going to find out how much we can fit inside the box. Okay, so I'm just going to measure it quickly. So we have the length of the box. Looks like we have 12 centimeters. 12 centimeters. Then we have the width of the box. We are at 7.5 centimeters. Okay. And if we were just doing a 2D object, that would be all we need, right? We would do 12 centimeters. 12 centimeters times 7.5 centimeters, and we would get 90 centimeters squared, okay? So the area of the base of this rectangular prism is 90 centimeters. But like I said, we want the volume, so we're adding that new dimension, we're adding the height. So now we have to figure out what the height of this box is. So I got 22.5 centimeters, okay? So now we're going to take the area of the base, we just figured it out, that was our 90 centimeters, and we're going to multiply that by the 22.5 centimeters that we have. Feel free to use a calculator for this stuff, guys, don't feel bad. So we're going to do 90 centimeters times 22.5 centimeters, and we get 2,025 centimeters cubed. We're not doing squared anymore, squares for 2D objects. When we get into 3D objects, you have to use cube, which stands for cubic centimeters, cubic meters, whatever. So instead of that little 2 that we put over the centimeters for squared, you're going to put a little 3 over now for cubed, okay? When we talk about volume, we always talk about cubic footage, okay? Or cubic meters, cubic centimeters, and that's just the way it is. Okay, so that's all there is to it. It's that simple, okay? There are obviously a ton of real life applications for knowing how much of something can fit into a box. If it's from construction, if it's from baking, if you just want to fill up your aquarium. Speaking of aquariums, it's important to remember, because a lot of the times when you do volume, we're going to be talking about fluids. So here's an important conversion for you. 1 cubic centimeter. So 1 cubic centimeter equals 1 milliliter, okay? So if you found out the box that we just did, we found out that it held 2,025 cubic centimeters. That means it would fit 2,025 milliliters, or just over 2 liters of fluid. If you look at it, that kind of makes sense. If you know, like your liter water bottle, this is saying it would fit 2 liters, just over 2 liters of fluid inside this box, which kind of makes sense, right? All right, so for the rest, this is just going to be plugging numbers, doing equations, looking at examples. I'm going to post something from the textbook for you guys. I'm gonna post some extra practice questions, and I'm gonna post an activity. The activity this week, guys, is gonna force you to do surface area and volume. Okay, you're gonna be working on them together. I think you're gonna be okay with it. I'm gonna post less than last week because some people were saying they're a little bit overwhelmed last week, and that's not. I don't want that. So a little bit less work this week. I'm going to be online normal hours all week, so reach out if you have any questions, if you're having trouble with this. I'm going to be working all week at getting your feedback for the stuff that you did last week, okay? If there's anything else, just give me a shout and we'll go from there, okay? Okay, so I hope you guys understand volume, length times width times height. That's all you need to know. All right, have fun, guys.